Hey everybody, welcome to Smart Operator Fundamentals Online Session 6 on this lovely Good Friday. If you're joining us for the first time, welcome. If you're joining us again, welcome back. Today we're talking about sound pressure level, measurement, monitoring, all about it, how to do it. Just this big old umbrella of SPL, and we've got Michael Lawrence joining me for this presentation. Michael, say hi.
Hello, how is everybody?
Awesome. So, we're gonna sort of tag team this one. We're gonna do a little buddy buddy flick for you guys. Because again, we're covering a lot of stuff, and we do have some people in the chat. I know there's some folks monitoring this discussion, but as we go, any questions, of course, support at rationalacoustics.com is the best way to contact us for any follow up discussion. So in our session today, we're going to cover, we're going to cover a few things. Now, of course, we have to define what SPL is, what it isn't, and then discuss reasons why we actually measure this. Is it because of legal reasons, personal accountability, just because we like to see numbers on a screen? Now, if we know why, then we of course have to get good data, and so we'll talk about how we're getting that data, the equipment that goes into this, and not just the measure microphone, but the entire signal chain, because it is dependent on a number of factors, the level that you can measure accurately. And of course, we'll end our video today with some interface tour of the SPL functionality in Smart. Now, the Smart platform version 8 introduced some pretty robust SPL measurement functionality. Just recently, in the last update 8.4, was sort of the expansion on what we'd already done with the original 8 release. So we essentially made Smart version 8 have an entire SPL monitoring and reporting suite into the program. And because of that, we split out that functionality. Actually, made a standalone program called Smaart SPL with those features. So we'll look at Smaart V8 and as far as SPL, and we'll also take a look into Smaart SPL as a standalone interface. So, Michael, can you tell us what is SPL?
So SPL stands for sound pressure level, and it's an objective measure of the strength of air pressure deviations that are caused by a passing sound wave. So a good analogy for this is if you think about a cork or a ball that's floating on the surface of the ocean, and at rest, think about how that level compares to how it's going to bob up and down on the surface as a wave passes by, and a bigger wave is going to make it bob up and down. So similarly, when we talk about measuring SPL, we're not talking about measuring the ambient air pressure. We're talking about how much that pressure is fluctuated by a sound wave.
Okay, so to put some numbers to this, so 120 would be about the threshold of pain. So that's where we're getting uncomfortable. How would you classify that?
Yeah, so we use a logarithmic scale to speak about decibel dBSPL. And so at the bottom of the scale at 0 dBSPL, we've referenced that to what we call the threshold of human hearing. So the quietest sound that a human can hear under normal conditions, we give that a value of 0, and we go up from there. To give you some context on how incredibly tiny 0 dBSPL actually is, the deflection of your eardrum from the sound wave at 0 dBSPL is about the diameter of a hydrogen atom. So it's pretty amazing that we can hear that. And at the top end of the scale, around 120, 130, that's where people will start to experience a sensation of physical pain. So hopefully everything that we hear in our day-to-day lives is going to fall in between those two extremes.
So what I'm hearing from you is that the higher levels, I mean, that's loud, but SPL isn't necessarily loudness. So loudness is perceptual. SPL is objective, right? SPL gives you a number to quantify data, whereas loudness, well, that's what's loud to you may not be loud to me versus someone else. So that's interesting because we have some weighting curves too when we talk about SPL, and I know they're done for different purposes. Can you sort of talk about how the weighting curves are created and what they're trying to accomplish?
Right. So as you pointed out, there's a difference between SPL and loudness. You know, loudness is objective. We're measuring that air pressure variance, and loudness is our human perception of that. And there's a lot of factors that play into that besides the SPL. And one of the things that we have to consider is that human hearing is nonlinear, and the how we perceive tone and tonal balance changes pretty drastically based on the SPL. So at lower levels, if you look at the chart on the right, you can see that it takes a lot more bass for us to perceive that as equally loud. And when we get up to higher SPL, those curves start to flatten out a little bit. So because human hearing changes over level, that was the basis for these weighting curves. So you can see the Z weighting curve is the green line. That's an unweighted SPL measurement. It's literally just the raw pressure variations happening at the mic. And the original basis for these weighting curves is, okay, let's try to produce a measurement that looks a little more like what it sounds like to us. So if we're measuring at low SPLs, let's roll off a lot of the low end in that measurement. You can see the A weighting curve there in red. And that's designed to mimic the human hearing response at low levels where we're not very sensitive to the low frequencies. And when we want to measure up at higher levels, let's use the C weighting curve, and that includes more of the low frequency in the measurement. The problem with that is it was based on data that's almost 100 years old now, and we now know that it's not very accurate. So that's why there's two sets of curves in the graph on the right. The red curves are the currently accepted equal loudness contours. And so you might be thinking, oh, gee, well, we really missed the boat on the weighting curves. Luckily, the goal of an SPL measurement is very seldom to actually produce a measurement that looks like it sounds. There are three categories of reasons that we do want to measure SPL, and they're all for objective purposes. So, Chris, why don't you talk about that?
Yeah, sure. So I like to think of measuring SPL in terms of event monitoring as basically personal and professional accountability. So personally, am I consistent? Am I reproducing a level that is the same day to day? If I'm tired, can I verify what my ears are actually hearing? Awareness of the level somewhere else. So professionally, if I'm a system engineer and part of my responsibilities are to make the same experience everywhere in a venue, whether you're front, back, or side of a stage, well, the experience that you get, level plays a big part of that. So if people are getting a completely different level in different areas of the venue, they're also getting a completely different show. So that's something that I'm personally accountable for as a system engineer. Now, professionally as well, so are there certain guidelines that you have to adhere to because of where you happen to be? Is there a certain desired level that the venue is requiring of you? Are you consistent day to day? Talk about nuisance monitoring. So what is the level that's causing trouble, not necessarily in terms of protection of hearing and damage, but just annoying people outside of the event. So I guess the third, we'd be talking about the nuisance portion of this stuff. So what's interesting about the U.S. specifically when it comes to requirements for SPL levels is that there really aren't any. There's no federal guideline. We have, of course, we have OSHA guidelines, and they're enforceable for industrial type applications, but not necessarily the entertainment industry. When you get into entertainment, most regulations are based on A-weighted measurement because that's what the industrial measurement is also stipulating. So the fact that an A-weight measurement ignores low frequency content, well, low frequency is the stuff that's going to cause trouble in terms of the neighborhood complaining, right? Low frequency doesn't care about the walls of the venue, doesn't care about, it's not going to die off with distance, unlike high frequency where air acts like a low pass filter. The low frequency energy just keeps going. So, Michael, I like this chart you have. Is so inside the venue versus outside the venue. So this is basically a comparative view of what's happening in the venue versus what happened out, and can we see correlation? Now, the thing here, when you're monitoring low frequency, especially for nuisance monitoring, it's much more difficult to take level away from the outside that's already happened. Once the low frequencies left the building, it's really difficult to turn it to turn itself down. Or other words, active noise cancellation and stuff. Imagine a giant pair of Bose headphones, but for your entire neighborhood. It's much easier to monitor in a venue and keep track of where the low frequency is while it's actually being produced. That way you can sort of mitigate the spill of that low frequency once it gets out. So, Mike, why don't you talk about some of this exposure business?
Right. So, this is the third category of reasons for SPL measurement. And like Chris talked about, sometimes we're just doing it because we want to know, and sometimes we're doing it because we want to make sure we're not bothering the people outside the show. And exposure deals with the people who are at the venue inside hearing the show. And so we're talking about how loud is too loud. And as Chris mentioned, there's a lot of subjective ways in which something can be too loud. Personal taste and artistic vision all play into that, genre expectations, and so on and so forth. So we have to be careful with our terminology here. In the SPL sense, when we talk about too loud, we are asking a very specific question: are we damaging people's hearing, right? And so a lot of people want a one number. Okay, well, how many dB is too loud? What's the magic number? And it doesn't work like that. There are two considerations when we're talking about sound exposure: how loud and how long are the two things we need to look at. So we can go to the next slide. So there are a couple of established guidelines for this in the United States. A lot of people are familiar with OSHA's permissible exposure limits, and it's a very common misbelief that OSHA permissible exposure limits will protect your hearing. They will not protect you from noise-induced hearing loss, nor are they designed to. OSHA is designed for industrial applications, and it's designed to indicate the point of liability with your employer. It's the point at which they are legally negligent because it's so loud. And so by OSHA's definition, after a career at these levels, 25% of people will still have noise-induced hearing loss. So NIOSH is where we look to if our concern is actually hearing preservation. NIOSH is the National Institute for Occupational Safety and Health, and they're under the Department of Health, and so they're a lot more concerned with keeping people safe and not damaging their hearing. And the one thing I do want to point out about this chart is if you look for how the sound level changes with the duration, right? So as the period you're exposed to the sound doubles under NIOSH, the level that you can be exposed to goes down by 3 dB. And that's going to be an important point later on. And if you want to dig into more of that, there's a great link at the bottom there for a NIOSH document that'll take you through all this stuff.
Sure. So when we look at different exposure, SPL requirements in other places in the world, what you notice in those charts is that you have a time period associated with the A-level exposure. So looking just at Austria, so it's a 100 dB over a 1 minute period of time, or Belgium is 100 dB over a 60-minute period of time with a variant. You look at Germany, there's the A-weighted and there's also a C-weighted level, because low frequencies can cause damage as well, right? The low frequencies are fatiguing just in the way that high frequencies can be as well. So now, if we have this time period component, well, the most common SPL meter that people are looking for, especially here in the States, is just an A-weighted, A-weight SPL slow. Right, so here's 30 minutes of a show measured at A-weight SPL slow. So what is the level? Right, well, it depends when. Right, so you can, at any given point, I mean, it can vary from 60 to 95 dB or more. So if we were to take this information, instead of looking at it as just SPL slow, let's look at it with a 10-minute integration period. So what's called a LEQ 10. And now we can see sort of an average level over this 30 minutes. Michael, why don't you elaborate a little bit more on what LEQ is?
Sure. So unlike industrial noise sources, where it's a pretty steady state thing usually, those metrics don't work pretty well for our purposes with live music because, like you pointed out, Chris, a lot of our music has dynamic range, which we just saw. So in order to make a meaningful statement about what was the level of this song or what was the level of the show, we're going to need a metric that gives us a larger view of the time than SPL slow, which is a 1 second integration time. So, seconds of context just isn't enough to make a meaningful statement about whether or not we're in compliance. So LEQ looks at an average over a longer period of time. That time is usually in minutes, and it's indicated in the suffix. So for example, on this slide, we have LEQ 10. That's a 10-minute average. And so that's going to give you a equivalent dB value for the last 10 minutes. And generally, as Chris mentioned, when we're talking about noise exposure, we're usually making A-weighted measurements. So if you see LAEQ 10, that's a 10-minute LEQ that's A-weighted.
Right. So now when we look back at this graphic here, so LA 1 minute, is the P a peak measurement, or is that what is the P here, Michael?
Nope, that's just pressure.
Okay.
So there's a bunch of different conventions for indicating this stuff. So depending on what source you see, you're going to see different subscripts like that.
Sure.
But this is so the example that you're pointing out for Austria, that's a 1 minute A-weighted LEQ measurement that has to be under 100 dB. Gotcha. And this is a good thing for us, because we want our music to have dynamic range. So if we use a 10 or 15-minute window, you can see that the mixing engineer can create loud moments that are exciting and quiet moments that are intimate and still be within compliance when we zoom out and look at the whole performance.
Great. So how do we actually get SPL data, right? So what are the pieces and components that go into acquiring SPL? First of all, we need to calibrate our SPL reporting device so that we know that it's accurate. And this is typically done with what we call a SPL calibrator. They used to be known as SPL piston calibrators or piston calibrators, where there would actually be an airtight seal with a piston pushing a specific pressure value against the capsule. We do this electronically now. This happens to be on the screen, the iSemcon SC1, which is a common SPL calibrator. And it produces a 1K tone at 94 or 110 dB SPL. So that calibrator would be connected to a microphone, and the microphone would be connected to an interface, and we would calibrate the interface's level with a specific preamp value to get a known level in SPL into our software. So all this stuff goes together, right? It's not just a microphone. It's not just an interface. It's the whole measurement loop. And we really want to get a system that can measure up to about 140 dB SPL. Why 140?
Oh, that's a great question, Chris. And a lot of people, when we say, hey, your mic should be able to withstand at least 140 dB SPL, they say, well, gee, that seems really high. I don't mix that loud. My shows aren't that loud. But if we go to the next slide, what you'll actually see is that the numbers that we're used to seeing on our meters are, again, there's those slow and those fast metrics. Those are integrated over time. And those are significantly lower than whatever the peak instantaneous level is at the mic diaphragm at any second. So we can see here, we have, this is a couple minutes of data from a concert, and we can see that the A slow levels are hanging right around 100, which is a pretty reasonable level for a lot of concerts that you might encounter. And at the same time, the peak C level, the instantaneous level, is 30 dB higher, and it's pushing 140. And so if your mic can't handle those levels that are 135, 140, you're going to clip. And clipping is a really bad thing when we talk about logging SPL, because as soon as we log a clip, your data is invalidated, and all those LEQ buffers have to flush, and so now our data is no longer reliable. So it's very important that we don't clip when we're doing this, and that's why we recommend having a mic that can handle up to 140 dB SPL.
Great. And just for those following along, this graphic here was created from Smaart's SPL history timeline, which is available in both Smaart version 8 and Smaart SPL. So let's see. I had mentioned earlier that the mic, the I/O, the whole system has to be calibrated together. Michael, we've got some interesting data points here. Can you elaborate on how the microphone sensitivity interacts with the preamp of a measurement, and how that relates to what sort of levels we can actually measure?
Sure. So once we expose our mic, we have to remember what a microphone is, right? It puts out a voltage for a given pressure at the diaphragm. And the larger that pressure is, the larger the voltage that's going to come out. And so the sensitivity spec of the microphone allows us to say, for a given SPL, here's how much voltage we're going to output from the microphone. Typically, that spec is given at 1 Pascal, which is 94 dB SPL. So what this means, if for the example that's on the screen here, the iSemcon mic, at 94 dB SPL, you're going to get 6 millivolts out of that microphone. And that's a reasonable mic level signal. But at 140 dB SPL, that output is going to be a lot higher. It's going to be 1.2 volts RMS, which is a line level signal. And so if your preamp isn't expecting a line level signal, you're going to clip. In the case of a more sensitive mic like the Earthworks M30, that has a much higher sensitivity, 34 millivolts per Pascal. So at 140, that mic is outputting close to 7 volts RMS. And not too many preamps are going to be happy about that level coming in. So when you choose a rig for SPL, you have to pay attention to not just the mic and the interface, but also will those work together. And a really nice shortcut for saying, okay, well, what voltage do I have to deal with here? I'm going to go check my spec sheets, and I'm going to make sure that my max voltage on the preamps is going to be enough. The number you want to look at is taking that 94 dB sensitivity value, which again for the iSimcon it's listed as 6 millivolts. If you multiply that by 200, that's a quick way of telling you what the voltage is going to be at 140. So again, you just want to make sure that when you're choosing your preamp and your interface, the maximum input voltage is going to be sufficient to handle what your mic's going to create.
So if I'm using an Earthworks, why don't I just put an inline pad on the Earthworks mic?
So the reason that you want to be careful with a pad is remember that the pad's going to also attenuate phantom power. And so you can actually decrease the headroom of your microphone as well. And so you're sort of chasing your tail. In that sense, you're going to clip sooner. So that didn't really help you that much.
Right. So let's see. How do we ensure accuracy with our measurements? Michael, can you expand on this, please?
Yeah, absolutely. So, the measurement's only as good as the accuracy that we're using to measure it with. And so the question people ask all the time is, well, isn't it okay to be within a couple dB? And the answer, like a lot of this stuff, is, well, it depends what you're trying to measure, right? So the first case that we talked about where you're a front of house engineer and you just want to have consistency from night to night, you want to hit the same levels every show. It doesn't matter what the absolute number is on the screen. We just want to hit that same number every night. So accuracy is not a concern for you. If you're up against a legal requirement that requires you to stay under a certain level, right? Now you have to make sure that you're in compliance with that level. So now we need the number on the screen to be meaningful. And where accuracy is of paramount importance is when we start to measure exposure. And the reason for that was what I pointed out when we were looking at the NIOSH chart earlier. Exposure works by equating the exposure time to a certain level. So if we are misrepresenting the level, if we're mismeasuring the level, that's going to give us an error in the amount of time it's safe to be exposed to that level. And so you can end up with a situation where it's measuring completely safe, but it's actually not safe.
Right.
And if we can take a look at the next slide, I'll show you exactly how that math works. What we did is we found out that even small errors in calibration, a couple of dB, cause relatively large errors in your window of uncertainty for exposure time. So what we found is that if you have a plus minus range of 2 dB on your calibrator accuracy, the window of uncertainty in your exposure time is as long as the event. And so at 2 dB plus or minus, you're not even making a meaningful statement about whether this exposure measurement, it doesn't really tell you anything meaningful because who knows. For that number to be meaningful, you really want to be within plus or minus 1 dB on the accuracy of your calibration. And that sounds like a pretty stringent standard, but the good news is that we are totally capable of achieving that.
Right. So when we talk about the microphone, the equipment that we have, there's these sort of two categories that things fall into. Either they're class compliant or they meet class tolerance, and they're not necessarily compliant. In order for something to be class compliantly accurate, the entire measurement system has to be certified together, and you can't have user adjustable settings on that system like a gain knob. Because if it's too loud, you just turn down the gain, right? Well, that doesn't work for class compliance. There's a frequency component as well, and so when you look at a microphone spec sheet, you may see that this microphone meets frequency requirements for class 1 response, or meets the requirements for a type 1 SPL meter. Now, that's great. But it doesn't mean that your equipment is inherently compliant, right? So for Smaart, for example, Smaart can be certified as class compliant, but it requires that your specific measurement system is certified, right? So it's not necessarily that out of the box you have that piece of paper. It takes another step of sending your rig to a lab, because that whole system, including the display, has to be certified together. So there are standards that we have to apply to. If you look at the standards, if you're the type of person that enjoys reading standards, you're more than welcome to go. But we've sort of put some of the bullet points here of where these things matter for SPL, and there's standards for type 1, type 2 SPL meter meeting class 1 or class 2 tolerances as well, and we'll have links to these standards in our landing page as well. So, Michael, I know you have a few of these handheld SPL meters. Can you tell me a little bit about this experiment you did here?
Yeah, so, if you're going to dig into SPL, the first question a lot of people have, they have two questions, right? Well, what about this handheld meter that I have, and what about my phone? And so real quick, let's just touch on a couple of those. So this was kind of a fun thing. We bought just a truckload of these things, and I spent a couple weeks just, putting them in freezers and doing horrible sorts of torture to them. And it's sort of like the old joke. If you have one SPL meter, you know exactly what the level is. And if you have several, you have no idea. And so you can see that these are all listening to the same source, and they're not even close to being in agreement here. There's a 6 dB plus variance. Chris, if you go to the next slide, please. So, a lot of these on the package will say either accurate to plus minus 2 dB or accurate to plus minus 1.5. And what I've learned is that I can't trust what it says on the package. This is something that we tested these with a calibrator as soon as they came out of the package. Next slide, please, Chris. And so what we found is less than half of these out of the box actually meet the standards that they say. And someone in the chat asked a great question, which is, well, how do you know your calibrator is accurate, right? So, and it's sort of, it's sort of the first mover argument, turtles all the way down, right? So the stuff that is certified as accurate will generally come with what's called a certificate of traceability, and this certifies that the measurement that we use to calibrate this has it can be traced directly back to the National Institute of Standards and Technology. So generally the more expensive hardware is going to come with a certificate, and that is a good reassurance that it's doing what it says. But of course, the best way to do that is to actually send it out and have it measured. Of course, the elephant in the room here, got my little elephant down there. The elephant in the room here is that if you're trying to use a handheld meter to make statements about exposure, how accurate these devices are is not really what we need to be concerned with, because as Chris showed earlier, what we really need to do is look at a longer window. We need an LEQ measurement for that to be meaningful, and most handheld meters aren't going to give you that. You will see them. They're generally more costly because they have to include a buffer, and they have to include an aperture, and they're logging data, and so there's a microprocessor in there. And so that's going to be a little more costly hardware. But generally, those are the ones that also come with the certificate of traceability. So it is possible to do LEQ with a handheld meter, but a lot of them won't do it.
Yeah, and just to touch on how do you know your calibrator is accurate? Well, when was the last time you changed the batteries?
Good point.
Because we're talking about an electronic device, and it's I know the iSemcon calibrator. It takes a 9-volt battery. If you don't change the batteries in that for a year or whatever, and you start to measure, expect it to not be accurate.
Right.
And I know the 10 Easy SC1 it meets type 2 tolerance. So even if you have a class 1 system measured with the SC1 calibrator, you are now of a type 2 system that meets type 2, because you go with the lowest common denominator in that case.
Right.
And I would recommend, if this stuff is, if making sure you have the most accurate measurement system possible in terms of SPL, once a year, get a checkup once a year, just like you go to the dentist or whatever. Just get a checkup. There are laboratories out there. There are places you can send this gear to be certified, and if we're talking about stuff that gets worked. I mean, this is stuff that's not necessarily babied equipment, and so it's important to just do a checkup every once in a while on your gear. I think this one's really interesting. So Michael, you had noticed in the spec sheet for the Radio Shack, it says this. These devious 2 words, slightly directional.
Yeah, so what one of the things we found was your measurement changes pretty seriously based on how you hold it. Are you holding it in front of your body? Are you holding it at the end of your arm? And in the case of the Radio Shack meter being slightly directional, what I found is depending on how you rotate it, it has over 5 dB variation there. And that's not the only problem with these little guys. If you go to the next slide for me, Chris.
Yep.
This is the frequency response of the mic capsule that's inside that meter, and with both weighting curves. And you can see it's absolutely not flat. And the reason this is a problem is because your reading is going to change based on the tonal content of the signal that we're measuring. So, you know, if you're using these things for relative measurements, a lot of these things live on the meter bridge of your mixing console. And again, you're just making sure you're hitting that same level every night. It's a great tool for that, but you want to be very careful about trusting what that number is telling you. I wouldn't want to make a legal decision, for example, based on that number.
Yeah, it looks like we have about an octave wide 6 dB boost here at 6K or so. I wouldn't call that exactly flat.
At least it's not in an important range, right?
Yeah. So I know you looked at some smartphones too. Why don't you tell me a little bit about what you found out?
So what we found out is that if you own an iOS device, the mics that are inside those are generally accurate to within plus or minus 2 dB. There are some outliers, but generally you have a pretty good shot. If you're using an Android device, it's no man's land. You have absolutely no idea what's happening with that. There's a couple hidden variables there. The first hidden variable, though, is that it also depends on the app. And so there's a couple studies here that you can see that we've cited in the slide for you to go dig into, and a lot of apps don't report the accurate level. So the NIOSH study, out of 130 iOS apps, only 3 were within that magical 2 dB window. So you have to be very careful about that. And the other thing that a lot of people don't realize is that even if it's totally accurate at 85 dB SPL, when it gets to concert levels, most phones go into hard clipping. And so I know my phone goes into clipping about 96 until I got caught in the rain at a festival last summer. And after that, the sensitivity went down a lot, and no one could hear me on the phone, but the concert levels didn't clip it anymore. So I don't recommend that approach, but that's something to be aware of. And if you go to the next slide for me, the other thing that we need to be aware of is just with the Radio Shack meter, the orientation of your phone will change the reading that you get because your phone's a boundary, right? It reflects sound. It's just like a PZM. Pressure zone microphone. So the interesting thing about this is that if you use a larger device like an iPad, it's a larger boundary, and so those deviations will extend to lower frequencies. So that's just some stuff to talk about, and I think the thing to remember is under what set of circumstances is okay for me to use this number as meaningful, and when should I maybe not trust that number.
Cool. So now I just want the simplest solution possible to measure SPL. I don't want to worry about the calibration. I just want to get something that gets me a number on the screen that I can rely on. And one of the things that we did here at Smaart was we realized, very early on that the hardware has to become something that is controllable. And so we ended up partnering with this company 10EZ out of Denmark. And I always question myself if it's Denmark, so if I'm wrong, feel free to chastise me later. But 10EZ, they make this really elegant solution. It's a microphone capsule. Actually, I have one right here. I'll show you what this guy looks like. So you get this I/O with a BNC cable and a USB and some lights that just show you what's working. There's no other connections. There's no gain, no phantom power. There's nothing to mess with, and a microphone with a Sirius capsule and a serial number that matches the I/O that you get. And so this system is calibrated together from the factory. This provides basically a turnkey solution for measuring SPL, and with the Smaart Analyzer, you can send this stuff off to a lab and certify that your rig is class compliant for either class 1 or class 2, depending on which 10EZ system that you end up going with. And we have a couple of links here. The US website has some information charts that relate to the US market, where everywhere else, feel free to go to 10EZ.com for the actual 10EZ user guide. While we're here, before we get to the software and take a look at the interface, there's a few more links I want to talk about just for more studying, because I know you all presumably plenty of time on your hands. We have a great SPL guide that we wrote, so a quick start guide that goes along with our SPL software. There's a ton of great information that I couldn't recommend it enough. And then we've also made a video. It's I believe about 15 minutes video walking through the interface as well. We didn't talk about calibrating Smart for SPL, and we're not going to in this video. Suffice to say, it's something that you need to do if you want to see accurate data. But we did make a video for calibrating Smart for SPL, and there's a link for that online as well. And then, of course, the SPL product page where there's goobs of more information. So let's see. Do we have any questions on this that we want to address before we go into the software?
Yeah, a couple of folks were asking about calibrators, getting their calibrators recalibrated. And as you mentioned, Chris, there's a couple of labs that you can send your calibrator out to or back to the manufacturer. So if you own a calibrator, we would recommend checking with the manufacturer directly as to what they recommend. But also, if you want to email us at support@rationalacoustics.com, we can definitely point you toward a couple of resources as well.
Mm-hmm. All right. Well, I will. I'll jump into the interface if we're ready to move on. So we'll start off by looking in version 8. Michael, you're still live, right?
Yes, sir.
Okay. You muted your mic, and it felt like a noise gate had turned on because that's exactly what happened. So all right, you're still with me. All right,
still with you, buddy.
All right, so in the version 8 interface, when you go to the input device configuration, config IO config, or if you're a ninja with the hotkeys, it's Alt A. You'll notice that for the device we have selected here, under cal offset or calibration offset, there's all these values of 0. So none of these inputs have been calibrated for SPL. Again, we're calibrating the input device. We're calibrating Smart. We're not calibrating our microphone. When people say, I have a calibrated microphone, that's actually a misnomer. Either you have correction files for your microphone that you can input as correction curves. We'll talk about that, I'm sure, at some point. Or you've calibrated your input device for a known level, but there's really no such thing as a calibrated microphone. It's a calibrated input. This category here for microphones is a bit of a legacy interface for the now discontinued Smart IO, where you could just enter a microphone sensitivity value, but unfortunately that product had to reach end of life. So none of these inputs are calibrated for SPL. If we were to calibrate them for SPL, we'd select calibrate, verify that we're on the correct input, put our calibrator into our microphone, and select calibrate. Now, of course, there is the video on the calibration procedure that you can follow along with as well. A handy thing here, just for some sort of quick math. Whatever level you have set for your calibrator, say if you have your calibrator set to 94 dB as its output and your RMS meter here is reaching -12. Well, if you take 12 and you add that to 94, you get 106. And so at that preamp setting of -12, that would be the loudest signal you could measure before you overload Smart. Not necessarily overload your preamp, but that's where you would overload the input. So with 10EZ, we've simplified some things where 10EZ, the actual I/O is read by Smart, and the calibration offset is directly imported into the analyzer. So we have that calibration offset there grayed out because it's a factory calibration. And so now, because we've selected this to be used, you can even use the 10EZ input as a spectrum measurement in Smart. So there's our 10EZ measurement down here. We're nice and quiet, but there's a 10EZ IO. So looking in the in plot or in program SPL meter, the single meter right here in the top right hand portion of the screen, there's no input currently selected. If I select the mic 1, which is not calibrated for SPL, and then try to look at the SPL values here that are default in Smart, you'll notice that they're all grayed out. We're not going to show you SPL information for a microphone that's not calibrated for SPL. As soon as I change that input to 10EZ, which is calibrated, you'll notice, boom, all the default SPL metrics can be viewed. So that's sort of the most basic view of SPL in version 8, and now we'll jump over to the actual SPL config. Before I do that, anything that we need to touch on, Michael?
I don't think so, but I just do want to remind people, or maybe clarify for people, that all of the functionality that Chris is about to show you is included both in Smart version 8 and Smart SPL. So as Chris mentioned at the beginning, Smart SPL is all of the SPL feature set from Smart version 8. So it's a great choice for a lot of venues that maybe don't need to take FFT analysis, but still want to be able to do all these measurements.
Yeah, and we're gonna jump over to Smart SPL after and take a look at this functionality in Smart SPL, and you'll notice the similarities. I'm gonna jump to SPL config. So this is part of the configurator. Oh no, there we go. So with our SPL configuration, like I mentioned earlier, Smart actually has a really considerably robust SPL functionality, and some may not realize it if you've only ever used Smart for your spectrum and transfer function measurements. There's a whole SPL program in version 8. So the way that we look at SPL meters outside of the main interface is with a grid. So it's a rows and columns, and you can configure them here in the meter display settings. So if I want to view, say, 8 SPL meters, I'm going to do 4 wide by 2 high. So there's my 8 SPL meters. We're going to make sure that these are all the 10EZ input, because that's the one that we have calibrated for SPL. And then we'll jump into looking at some of the default SPL metrics that Smart is going to display. So to show the meter, you can either select on this button here, or press the hotkey E. E is an epsilon on your keyboard. So there's the 4 over 2 grid that we've configured, and you'll notice there's the 10EZ maximum average manager, and we're gonna explain what that is in just a moment here. So I'm going to make these full screen. So we have, for each of the default SPL metrics, we're calculating those basically as soon as the input is calibrated, or in the case of 10EZ, as soon as the program launches. So we have our peak C measurement, and then let's take a look at, we have SPL A and C weight, A, C, and unweighted. Both fast and slow. So the first 6 measurements are your unweighted fast, A-weighted fast, C-weighted fast, and then the same but slow. We give you default LEQs of 1 minute and 10 minutes. So again, unweighted A and C, unweighted A and C for both 1 and 10 minute LEQs. Now if I select an LEQ value, you'll notice that in the meter we have now a green bar across the screen. So what this is just showing us is, have we filled up our LEQ buffer? In the case of 1 minute, has this SPL meter been running for a minute or not? This is an LEQ 10, and so we're still filling up our 10-minute buffer. Now we can reset the LEQ buffers if we need to by right-clicking on the input, and we can clear the max values by selecting on the button here that'll reset the max value for that input. And when we change the view, when we change what we're actually looking at, we don't lose the information that's in that buffer. So if I were to go to, say, an LEQ 1 and then switch to 10 and then switch back to 1, we're not losing that buffer. That buffer is being calculated in the background, and it's just we're just displaying that. So it's a running measurement, which is a really important thing. And anyone coming from version 7, if you're using DI as well, you'll notice that when you change the display of the SPL meter, the buffers are reset. So this is a really powerful function of 8 and SPL as well, Smart SPL as well. So let's take a look at the upper portion here. So this is the 10EZ maximum average meter, or also commonly referred to as MAM. And so what this is basically an ongoing SPL bank account, right? So in the case of this configuration, our limit is set to 103 dB, A-weighted for 15 minutes. And you can see that here in the bottom of the screen, we have our 10EZ maximum average manager config. So again, the limit is 103 at A-weight and a 15-minute period of time. So what this is doing is basically an ongoing prediction of, at whatever level you're at now, how loud can you go before you use up all of your available dBs, and essentially go over your limit. And each one of these rectangles represents 1 dB. So we're down negative or positive 6. In other words, we could turn up the system by 6 dB or more in this case, and still be within our 103 limit. If we were to start to get really loud here, or the mix engineers really pushing the system, then these red blocks will start to fill up. And so at that point, it's just saying you need to turn down. If you don't turn down, eventually the interface is going to start giving you warnings and alarms that you need to really think about adjusting the level of the system. So I don't know if I can make this go over limit in the 15-minute period of time just by talking into it, but we'll see. There we go. So we've got some action. So as I speak into the 10EZ the capsule, you'll notice that we've lost our green blocks, and eventually we're going to start filling up some red, I would presume. There we go. We got one. And then so that's just saying, turn down the level, in this case 3 dB, to reach your target 103. So if I were to keep talking to the microphone, keep making loud noises, eventually the interface is going to tell us, hey, if you don't turn this thing down, you can't come back eventually. Let's see, we've got some more options here. Before I go on, do we have any questions about 10EZ before I show some of the more advanced functions in the SPL?
Well, there were a couple questions related to the topic that I just want to touch on. Someone asked, what about B weighting? And for those of you unfamiliar, B weighting, it's halfway in between the A weighting and C weighting curves. And the reason that you don't see it on modern equipment is because it was removed from all of the current standards, I believe, except for maybe 1 or 2 obscure ones. So that used to be in the standard. It's no longer in the standard. So any modern gear is not going to include that weighting curve. So that's why you don't see that. The other question that I wanted to address real quick is, why do we use A weighting for exposure? We're talking about hearing damage, and at concerts have a lot of low frequency energy. So why are we only using an A weighting curve that ignores that? And there's some great information on this in the NIOSH document that we linked in the slideshow. But the short answer is that the A weighting curve actually tends to correspond very well with hearing damage. And so although it wasn't originally designed for that purpose, it's a really great estimator of that, and it does allow us to make objective and accurate statements about how loud is too loud, so to speak. But that does not mean that low frequency doesn't cause hearing damage. You can absolutely damage your ears with low frequency energy, but it has to be a pretty high level. Most of the data that we have on that comes from like NASA, like rocket ship levels of that's how loud it has to be. But if you were in, for example, the front row at an EDM festival for 8 hours in front of the subs, I would have concerns about that. So hopefully that clears that up.
Yeah, and if any of you have ever experienced a really excessive low frequency energy, for example, like low frequency feedback or something, and your ear just, it's that hurts. There's certainly damage there. But when you say why A, I don't think there's one size that necessarily fits all. I mean, for me personally, I'm looking at several different values at the same time. I want to know the A weight slow. I want to know C weight slow. I want to know maybe a 10-minute or 15-minute as well. So I having one SPL meter, I don't necessarily consider that to be enough, depending on what information you're looking at. To me, the base ratio of the system, A to C weight, is really an interesting number, and so I want to see both A and C as well. Anyway, so now these are just the default values here in this drop down. So that's just what Smaart's giving you by default. Now, if you need to make custom meters, say an LEQ 15 or 30 or 60 or whatever the time period might be, we allow that. There's no actual limit to the amount of SPL meter types you can have. So by selecting on advanced meter config, you are given the opportunity to add as many as you like. So you can change the 10 minutes to be different. You can add another meter. Say I want this meter to be instead of 10 minutes, this one's going to be 30, and it's going to be an A weight. And then I want to add another one that I want to be not 30 but 30 minutes, but it's going to be 30 seconds. So I'm going to write an S after that, and so now we have a 30-second LEQ. And we'll do a weight for that one as well. Now I'm going to do one more thing here. So this is going to be 30 as well, but instead of seconds and minutes, I'm going to do hours. So this is going to be 30 hours. What's 30 hours? That's 1,800 minutes. So there's that. And this one will also be a weight. So just to reiterate what I just did, we have minutes are the default. So you type in a value and don't put anything after it, you get a minute. If you type in a number, then put S, then that's that number in seconds. Then if you type a number and put H, that's that number in hours. So we can also do exposure based on OSHA or NIOSH. And so these are basically running percentages of level based on the permissible exposure limits, which you saw in that graph from the slideshow. So what these meters are, and let's look at them before I go on. These meters are running predictions, and so because we're below 85, nothing's happening. These meters don't even calculate. The data below 85 is thrown out. And is that 85 for both, or is it 85 and 90? Just refresh my memory, Michael.
Sorry, what was the question, Chris?
Is it 85 dB for NIOSH and OSHA, or is there the levels where?
Oh, I'm sorry, you're talking about the lower threshold.
Yeah.
Yeah, I believe it's 85 for both.
Okay, so once we get over that level, then the exposure limit starts to calculate, and it's basically it's a percentage. In the case of Smart, we go up to 100%. We keep going, so you can go to 1,400% exposure, but after you reach 100, you've been exposed. I mean, that's the point where you should, consider, if you're not wearing hearing protection, put some on, or stop, stop listening to the level. You've reached your exposure for the day. So,
yeah. Chris, if I can just chime in on that. Yeah. One of the things that we found out when we talked to NIOSH when we started developing our SPL features, we had some questions about this stuff, and so when we talked to the audiologists at NIOSH, one of the things they were careful to point out is it's not all about let me hit this exposure 100% target and then I'm going to call it a day because that's my dose. We don't know what you did the rest of the day, right? So if you mowed your lawn or you ran a snowblower or you were at work running a power tool, all of that will kind of cut into your dosage for the day. So that's why it's important to keep an eye on this in terms of overall exposure and not just set, I'm going to go for 100% exposure dose as my goal for the show. That's not necessarily the best approach.
Yeah, and I'm going to talk into this microphone just a little bit, just so we can start filling up the exposure. And you'll see, because my speaking voice is getting to the capsule above 85, we're starting to fill in this exposure. So you'll notice that NIOSH will fill faster than OSHA. Again, the NIOSH is a little bit more strict than OSHA is in this regard. All right. So what else do we have for advanced meters? We have one more thing we haven't looked at, and that's the fact that we can do octave filtering of either LEQ, is no weight, A weight, or slow. So this happens to be dB SPL unweighted, and I can go to octave, and we can measure the SPL for specific octave bands. This is a really handy tool for low frequency monitoring. What is the 63 hertz octave band? What is a 30 hertz octave band? What is that energy that's just the energy that doesn't care about venue boundaries? It's just going to keep going. If you're, like I said earlier, if you're getting complaints from the neighborhood, they're not complaining because the snare drum's too loud. and they're not complaining because your snare drum doesn't sound very good, but maybe they will just to rib you a little bit. But what they're complaining at is that they can't sleep, when the concert's going, because their low frequencies rumbling them or rumbling their house or whatever. And that's the kind of stuff that we can monitor with octave band really effectively. So you'll notice that we have some color changing here. So green and white have been the predominant colors we've been looking at so far. Now the color of the meter is configured from the meter display settings here in the left of the SPL, and we can change where where we call traffic, the traffic light warning color changes for each meter that you've configured independently, or you can apply your settings to all meters if you choose to. So a common thing here is what you might want to change the low frequency, the SPL types that are letting in more low frequency to like peak C or C weight, no weight. Maybe you change the red above to be a bit higher, so they're not just constantly in red during your event, and say maybe they turn yellow just below as like go just below as a warning. So 3 dB below that, and then green above 80. Okay, so so this peak C measurement is not going to turn red until we get above 120 or above. This is a really handy thing. Again, this is something that I really like to do personally, is just have my C and A weight measurement where the threshold of color for the C weight is as much higher than the threshold for the A weight. But of course, there's a default setting there that you may want to change. And then, so if that's the warning, we also have alarms. And so alarms can be configured for either all inputs or, let's see, we'll start over. So we can have an alarm that's configured for all calibrated inputs. So basically, we're monitoring all the inputs that you have at once. If any one of them reaches peak C of 110 or more, then the analyzer will go into an alarm where the screen will flash, the meter will flash, and indicating that you've reached an alarm. So you can also have an alarm based on per input basis, and you can also have an alarm that you can have different alarms for the same input. So say I want an alarm for C at 110, but I want to go over the alarm for A at 100, right? So it's just telling Smaart where to trigger an alarm. And now let's segue into logging from here, because if you're logging SPL and you hit an alarm, that alarm's going to be written to that log file. The meter grid, that's just a display function. That's not going to be written to the log file, but if you trigger an alarm, that will be written to the log file. So let's configure Smaart for logging. And so log config. And so the operator happens to be me. I'm Chris Tinger, so CT. Company is Rational Acoustics, and the venue is the Worldwide Training Headquarters. And we have our calibrated input automatically selected. All right. So our interval is 3 seconds. So that means that at that setting, once I start logging, at every 3 seconds, we're going to log the max value for each of the metrics that we've created within that 3 second period. So in this case, because I made all those custom advanced meters, we're going to log every single one of these. So I'll go ahead and start that log. If the button is red, we're logging. If I were to turn off the software without stopping the log and then turn the software back on, we're going to start a new log. It's going to just keep on going with the same log config, but a new date and time. So let's take a look at the SPL history window. So as you can see, every 3 seconds, there's a new data point. And here we can choose which of the SPL meters we want to see. So I'll just bring them all in. And the bottom plot here is going to automatically resize to fit all the data. If you've ever used the IR module of Smaart, you'll see this this looks familiar because it's very similar to the navigation pane and the plot area in the IR window of Smart, but there are some significant differences. So the bottom area here, whatever measurement that is atop of the Z order is the measurement that we're looking at in the upper navigation pane. So just like we have a Z order in real-time mode, we have a Z order here in SPL measurements for the SPL history as well. So we'll put the C. We'll do this. We'll do SPL C fast will be the top measurement. So we're looking at the full file that we created. So the left axis here, this is basically time 0, and then all the way on the right, this is our real-time data coming in. And by real-time, I mean every 3 seconds. And then you'll notice there's these 2 little widgets here that we can bring in and move around. So what these widgets do are determine the zoom range for the bottom plot. And so I could even specify that I want this time range to be, I could say 1 minute. So we'll do 1 minute. And so now there's my 1 minute zoom range. And I can grab that, move it around, and zoom in on a specific area. If I take this zoom range, put it all the way on the right hand of the screen, then this bottom plot is going to update in real time. As soon as I take this off of real time, or the right widget's no longer at real time, then the bottom plot here is essentially paused. We're just looking at what's in this window. So now let's take a look at the other bits that we have here in the very bottom of the screen. So we've got our max value, our L10, L50, and L90. So the max is whatever the maximum value is for the metric that is at the top of the Z order within this time range. And the time range can be that 1 minute, or it could even just be the full file. The L10 is basically the loudest 10% of level. L50 is the statistical sort of average, and the L90 is the level that we're above for 90% of the time. So for more information on that, please take a look at the SPL guide. This stuff is detailed out in there as well. Now on the right, where we have this button, generate report, and add note and reset LEQ. So we can if we reset our LEQ buffers. Are you sure? Yeah, sure. So now there's a vertical hash here that's written to the log file saying that you reset the LEQ buffer there. So we're not going to let you get away with resetting the LEQ buffer without noting that in the log file. If we add a note, so that'll add a time-stamped note to the header of the log file as well. So we'll say I'm going to call this 3 p.m. because looks like we just reached 3 p.m. And then generate report. This is a really cool function here. So if you've been monitoring SPL, logging SPL for an entire festival, for example, for a whole day, and you want to create a report for specific performances within that day, you can do that by zooming in on a band, right? So say the Rolling Stones performed in this time slot, and if I generate my report, it's going to generate the report just for that time slot. And so this is going to create a page that can be printed out or sent to a production management or whoever need be with the information that you fill here, any notes, as well as the max values for everything in this log file. If I take the widgets and go back to the full time range and then generate the report, it's going to generate that same report, but based on the entire log file. So I'm going to stop logging, and I'm going to show you guys what this log file looks like in terms of text. Okay, so we'll stop that log. So just like traces and config, all that stuff lives on your hard drive, so does the log files we generate. So if I go to Documents, and then I go to Smart V8, and I go to Logs, and I go to, oh, it looks like we have a couple things already in here, but I'm going to see if I can expand this. All right. So there's the log file we just created with the 10EZ mic, and you can see there's the time-stamped information of today. So this is a text file that if you open up in Excel, which makes things nice and easy, the data in that text file is automatically put into rows and columns for looking at. So the file that we create, we've got creation date, and then all the pertinent information that you put. So this is where we had set up the log file, the software versioning, the 10EZ config in this case because we're using 10EZ as an input, and then as a summary we have the max values for all of the different things that we were measuring. There's an asterisk next to all the LEQ measurements because I reset the buffer. That's just saying, hey, these buffers have been reset. And then there's the time-stamped note, 3 p.m., followed by each 3-second interval for each metric we calculated. And I had mentioned something earlier, the base ratio, the C minus A, being something that I like to know, and we actually calculate that. So for the LEQ measurements, you'll see there's the base ratio, C minus A. Or for all intents and purposes, it's a base ratio for what we're doing because of the nature of a C and A weight measurement. All of these values here, these 3-second values apart, when you look at the history graph of Smaart, that's what's being written to this graph. So this window is essentially a viewer for that text file, which puts all that information into a nice graphic that you can print out, screenshot, print out, and in case you don't want to look at it in text file. And this provides, again, for some really handy ability to zoom in, zoom out, generate reports on specific information. That log file we had just looked at, if I were to generate a report of, say, just this time, we're going to create another log file. Same idea. It's just it's not going to have all of the individual timestamp information. So the report that we generate is basically the header only, so a simplified version of the full log file. How are we doing over on the chat land? Do we have any questions or comments?
Yeah, we have some really interesting questions. The first one, I was wondering if you could talk about a couple of people asking about the 10EZ system and how you deal with wind. Are you using a windscreen, or what's been your experience with that, Chris?
Yeah, I mean a windscreen's fine. It comes with a windscreen as well. If you're worried about the frequency response effects of a windscreen, they're extremely minimal. But you're not going to generally notice a huge change as long as you're not talking about extreme storms. And if you get to the point where you're talking about extreme storms, your event's probably already been canceled. So if you need to permanently install a system somewhere, and so sort of moving from the use case where you're just at a front of house position or similar, and you pack up and go. There is a what's called an outdoor protection system that we can use with 10EZ or other microphones as well, and it provides for a weather protected solution, and even more, it's bird protected. It's got a little tower with some pointy things that stick out so birds can't make a landing on it. It also has a water, what's the term? Hydrostatic, is that the term? Hydrophobic. Has a hydrophobic filter, so water is going to be sort of rejected as best as possible. That's acoustically transparent. And there's even an option for a heating element. So if you're worried that you're in the Arctic tundra, you can even connect a heating element to the outdoor protection system. And 10EZ isn't the manufacturer of that. That's actually manufactured by Semcon, but the 10EZ microphone does fit into the OPS.
And I just want to just reiterate, because it seems like maybe some folks came in late, or just to make it more clear, the 10EZ system is a closed system, so it doesn't deal with your interface that you use. You don't set a preamp level. It's a closed tamper-proof system that you plug straight into your computer. So as Chris showed when he started this section, you plug it in, you're calibrated, you're ready to go. So that is the advantage. Somebody said, well, if I can do SPL logging and I can calibrate with my own calibrator, why would I buy the 10EZ? And so it comes back to the question of compliance. If you're in a situation where you're in, and this information may end up in a court of law, it may be legal evidence, we need to have a higher standard of proof. And so it's not about necessarily just how accurate the measurement is, as well as how well can we trust this data. And so if you need class compliance, that's a reason that you would look into a 10EZ system versus sort of cobbling your own kit together. Chris, do you have any comments on what I just said?
Yeah, just one more thing. It's how simple do you need it? Is the person that's operating the SPL measurement system, are they a qualified sound engineer that will understand how to calibrate a microphone and follow a procedure to do that accurately? Because simplicity, a 10EZ system is just you connect the USB cable and launch Smaart, and you're calibrated for SPL and start logging, and now you're logging SPL. So there's certainly something to be said about the both accuracy as well as the simplicity that a turnkey sort of system offers.
Cool. And one last question that I just want to get to. Someone asked, can you offset your calibration to compensate for hearing protection that you're wearing so you can get an accurate NIOSH dose? And the answer is yes. There's a bunch of situations in a lot of countries' requirements. They require the SPL to be measured from the loudest area accessible to the audience, which is generally closer to the PA than front of house. Now, obviously, it's difficult to get a mic position there during the show. So one of the things we can do is like an offset measurement, like we looked at the slide from earlier, inside and outside the church. If we know that it's 7 dB hotter down front, you can take that into account in your calibration. In the specific case of hearing protection, it's a little tricky because the effectiveness of hearing protection, it varies pretty significantly based on level. So to just say it's a certain number of dB attenuation is not super effective. And I have done a little bit of research on that. So if you want to send us an email, I can send you some resources. I think that's pretty much it. Chris, anything else?
No, I think that's good. I'm just about to jump to something.
Fantastic. So we're gonna look at also the web viewer, and we're gonna look at Smaart SPL's interface, correct?
Yep, that's what's left. I was just queuing up for that. So I think I'd mentioned the Smaart API in last Friday's session. So we talked about using DI or Smaart with third-party applications, and we can both control Smaart from itself, as well as remotely from the client window. Now with SPL, we took this a little bit further, and we added the ability to view the logging SPL information from remotely via a web client. So any browser connected to a network that the computer hosting Smaart V8 or Smaart SPL is also connected to. So I've enabled the the API here in API options. And I'm going to now open up the web browser for this computer, so Safari in this case. And we're going to type in, because I'm using the same computer I'm using for to view the web browser as that's generating the information, I'm actually going to type in localhost and then the port, which was 26,000. And so here we have the remote web browser for what we're currently logging. So, Michael, can you elaborate what you would do if you are trying to access this information but not from the same computer? How would you go about entering a URL?
Sure. So in Smaart's API config, you're going to see all of the available IP addresses and your computer's host name. And so entering any of those into any machine that is connected to the same network should get you to that web viewer. You can actually access this if you're willing to do the proper port forwarding and port configuration on the router that's running your network. And if you can get this forwarded to the internet, you can actually check this from anywhere in the world that you have internet access. including smartphones and stuff like that. And I also want to point out that you can access many different web servers in different tabs. So if you're doing something like production for a festival and you've got a lot of different stages you want to keep an eye on, you can pull all of these up from the production truck and keep an eye on that.
Right. So this is really cool. I mean, because guess what also has a web browser? Your iPhone, your whatever you're using. So, connecting to the information from SPL can be done basically to any device that has an internet connection. So let's get out of version 8, and I'm going to open up Smaart SPL, and we'll just take a look at how that program differs from version 8. So remember, the functionality in 8 for SPL and the functionality in Smaart SPL it's the same functionality. It's just that the SPL program is a customized interface for the SPL measurements. So rather than having a plot area with RTA information or transfer function or impulse response information, we have an interface where our plot area is the navigation pane of the SPL history as well as the detail area. And then this top portion here is where we can see any calibrated input. So if I go to input config, and let's see, where did we go wrong? What happened? Let's relaunch this. It looks like there's a communication error with trying to have both at the same time. All right, so when I launch Smaart SPL, it's going to see that I have a 10EZ system connected, and so right off the bat, there's the 10EZ input. So if we had more than one calibrated input, each one is going to take a place here in this bar, and so this is just a landing zone for your inputs. You can show or hide that interface element as well as any of the other interface elements, up to a full screen of the SPL navigation. Now, because we don't have any data, there's nothing showing. So obviously, Smart's saying please select a log file. The control bar here on the right side of Smaart SPL, again, it's basically all that stuff that we saw in version 8. It's just it lives here instead. So you can start and stop logging right from the top of the interface. You can show your meter grid right from the top of the interface. Any configurations that you would want to do can be accessed right from the top level of the interface. And so rather than having input config, measurement config, and SPL config, it's just a simplified version of the configurator specifically for Smaart SPL. If you launch Smaart SPL and you don't have any inputs calibrated, the first thing you're going to see is this screen, and the calibrate button is actually going to flash for you, indicating that you have to calibrate SPL, because to run Smaart SPL without a calibrated input, well, you're not going to be able to generate any data, but you can just use it as a data viewer. So if you were to load a file that we've generated before, like the one we had just created, let's do not Flash, documents, version 8. Oh. Not a valid log file. Well, I'm not sure on that one, but we can essentially use it as a viewer for data that is a valid log file. So more on why that mismatch was later. Again, SPL is just a taking the functionality in 8 and putting it into its own sort of house. Very much in the way that DI version 2 is the real-time functionality of version 8, but put into a simplified interface. So, do we have any questions on Smart SPL from the chat?
No, I think we've pretty much covered everything, and I just want to remind folks that in addition to being able to view this presentation later, you can also go to the Rational Acoustics website. You can download a demo of Smart SPL, and we've been talking a lot about downloading the V8 demo, but I want people to know that we want people to know that they can also get an SPL demo, and we actually have some sample log file data as well. If people want to download that and play with that and check it out, they can do so.
Cool. All right. So if that concludes it, then it was great talking to everybody, and thanks for hanging out for the last almost hour and a half. So
Absolutely. Thanks, everyone.
Great weekend.